Hey, physics, we're going to do a little lab kind of activity here. I'm going to collect some data. I'm going to show you, you're going to go into Pivot and you're going to find this ball toss lab. And I fixed this up. I figured out the way I want to do pivots a little bit better. There's only one point attached to this. This is not where your real points are going to come from. You're going to write up a little lab report for this. The only question is this one. I'm done. Because really what you're going to do is you're going to collect the data here, and then you're going to move it into Logger Pro or Graphical Analysis 4. I want to use both of those programs, so users of both of them have some examples of what it feels like to use them. So for this one, I'm going to do Graphical Analysis 4. If you're using Logger Pro, it's all very, very similar. All right, so let's check out this video. I'm just going to watch it. Kick back. I don't know, watching things in free fall in slow motion, pretty satisfying if you ask me. So we got 5 objects there. It looks like they're different sizes, but doesn't look like it matters much which one we pick, does it? Looks like the motion's the same. So I'll pick one of them. So here's what I want you to do. Let's go into our tools. Going to need a little measuring type thing. I can move that up and down. And looks like the way this one is set up, it's set up to go from negative positions up to 0. So, all right, fine, we can do that. So let's see, if I play, go back to the beginning. And this my friend, oh, sorry, let's go back here. Woo, that's fun. Let's see, this is my frame by frame. I'm not really interested in the ball's position when it's still in the person's hand. I really like this one in the right here. That is a beautiful pelota right there. So let's see. That out of person's hand. I think I'll go ahead and start right about here. And really, you know, I would like this to be position 0. So I think what I'm going to do is I'm going to go ahead and every time I'm going to measure from the bottom of the ball. So let's see. I'm going to get that 70 lined up there. So that negative 70 right there is lined up at the bottom. So I'm just going to record the data here, the positions as they are according to this, and then I'm going to fix them once I get into my program. I'll show you how to do that in case you don't know. Okay, so I need a stopwatch. And I want that to be 0 right there. That's my time 0. And then I'm going to scoochie this window over here so I can also have a I don't think I want that to get smaller. Okay, and I have my graphical analysis window over here. And here I want to do, I already went in and clicked manual for the data entry. I'm going to have time. And the units right now, as they are, are seconds. And then here I'm going to have position. You know, Y is not a terrible name for position here because it's like up-down position, but I don't want to seemed like I'm lazy and didn't do anything. So how if I do Y position? You could just call it position. I guess I would be okay with that. All right, so that's ready to go. And my first data point is going to be at time 0. Now I'm going to go over here back to this and advance 1 frame. And how many frames do I have? I don't want to like go too overboard here with the number of data points that I have. So I just want to see how many frames there are. Maybe if I just do this. I think the suggestion in the original pivot was maybe do every like 0.05 seconds, and then you get about 14 data points or so. So let's see. Yeah, I think let's do that. Okay, so I'm going to go in and do 0.05, and then 0.10, and then 0.15. And that's as far as I'm going to go. You're going to go all the way till it comes back down. So you'll go all the way up to 0.7 there. That should be about 14, 15 data points, something like that. Okay, so let's find our positions here. Let me go back to go away. I don't know why that little, there we go. Back to the start and back to my time 0. Maybe it's faster to get there this way. And 1 more frame. Oh, there it is. So, okay, so right now I am at position geez, I don't really like the way that this doesn't line up. You know what? I'm going to measure this ball instead, because then I can just line up that -60. Oh, this will work fine. Okay, so we'll do this one. The bottom of the ball is now at, it looks like, I'm going to say -58 centimeters is its position. And then I'm going to go up to 0.05. And there's 0.05. Now the position is, looks like -43 to the nearest centimeter. -43. Sometimes my eyes water from staring at this damn computer screen so much. So excuse me, wiping my eye. Okay, now I need to go to, oh, look at that. Bam, right on the nose. Okay, so that looks like I'm -30. And I'm going to go 1 more. And that's what's my position, -19. All right. So you're going to collect all that stuff, and you're going to put a nice title on your graph. And now what do I have? I've got, just hit enter there, or click down here so I have those points. Okay, that's great. I would like to see the origin in my graph always. So I'm going to go into my edit graph options. And in this case, the top of this needs to be 0. The bottom of this is 0. Well, that looks good. I might as well add a title while I'm here. This is Y position versus time. Okay, so there's the beginning of my position time graph. Now, I also want to have a new data set. Actually, you know what? I don't really need a new data set. I just need a new column. So let me go to here and add a manual. Actually, first I'm going to add a calculated column. You know why? Because I don't like the fact that this starts at -58. So I want to just start at 0. So here, and I think also if we want to be in SI units, I think we want to be in meters. So this is Y position adjusted. All right. I need to give it, I can't call it Y position because that's already taken. So you got to call it something else. Insert expression. So what do we want to do here? What I want to do is I want to subtract, actually I want to add Y position. I want to add to that 58 so that this will become 0 plus 58. And then will it let me do another? I guess I have to do another calculated column. I would like to now multiply this by 100 so I get it into meters, but because it's not going to let me do that. So there's that. And then I'm going to make another add calculated column. This is a little bit easier to do in Logger Pro, in my opinion. So this is Y position adjusted to. Going to be in meters. Oh, I guess the units for this one, that's not meters. So I have to go back and edit that. I think it'll let me do that. Insert expression. So now I want to multiply by, oh, I don't want to multiply 2 times together. I want to multiply I guess we can do this. So parameter A, when multiplied by 100, that's Y position, and then my there. Maybe I could have done it all here. I guess I could have. You can figure out that if you want. Oh, whoops, no. That's wrong. Should divide by 100. Column options. Here we go. So delete that. What I need to do is x divided by a. I guess I just need to multiply by 0.01. There, that should do it. And then raise that. Oh, I guess this will work, right? Multiply by that and then raise it to the first power. That's good. So does that look? All right, there we go. Now I got my positions in meters. That is good. So I want to go back to this, and I would like to be looking at the graph of that. So let's turn that one off, turn this one on. So now I'm looking at a graph of Y position adjusted to, which is in meters. And I'm going to my graph options. I'd like to go from 0. And that looks good. Okay, so that was a little bit of work there. Of course, you're going to have your whole columns here. So you can do all that by hand if you want, make your new column, but I like to use that new column, calculated column feature. All right, now you can do a curve fit for this if you want. And you know, if we expect that these things that are under the influence of gravity have constant acceleration, and your graph, you're going to have a more complete parabolic looking thing, you could go to the graph tools and apply curve fit. Linear, I don't think so. Quadratic, yes, please. You can do that and apply that and make sense of all the numbers in that. So I'll leave that for you to do. Now, the other thing you need to do is make a velocity time graph. And I'm going to show you how to do that. To make a velocity time graph, we are going to need a new manual column. And the title of it will be velocity. And the units will be meters. Now, how are we going to get those velocity values? I'll tell you how. You can do this by hand, like with a calculator by hand, or you can use the linear fit feature here. What I would like to do is I'm going to use a little bit of calculus knowledge here and say, if I want to know what is the slope of the tangent line to this curve at this point right here. Well, I don't really have a way of doing that because I don't have the equation. You have an equation, but you don't want to use your quadratic fit equation for this. What I want you to do is this. I want you to look at these points and say, you know what? If I pick those 3 points right there, the slope, if you draw the secant line that connects this one and this one, that's going to be a really good approximation for the slope for the one in between. So let me just draw a little picture for you. In case you don't believe me, it's hard to tell with this little bit of a graph because the points are, they're kind of close together in terms of the time, and it's not very bendy. But if you had a curve like this, and you had 3 points that were equally spaced in x values, even if they weren't equally spaced, I think this would still be true, right? If you draw the secant line, in other words, connect those two on either side of this point, the slope of this line right here is a really good approximation for the slope of the tangent line for the point in between them, okay? So we're going to exploit that fact to get our velocity data. And we're also going to note that if I do a linear fit here, that even if I include this point, if I go right here and do apply curve fit, linear, that slope that I get right here, 2.8, that's going to be a real good approximation. Now, you just have to be careful. It's a real good approximation for which one? It's a real good approximation for what the velocity is at 0.05 for this one right here, our second data point. Now that's about 2.8. Right? And we're not going to find this velocity here at time 0. We're not going to bother doing that one because I don't have another point on the other side of this to use. So the first one that you find will be here. Now the second one you find, I'm going to select these 3 points and I'm going to do my little linear fit again. Apply curve fit, linear, and now that's 2.4. And that's the last one that I can do because I only have 4 points. You're going to have a whole bunch. The only ones that you can't get are going to be the very first and the very last because you don't have a point on the other side of those. So that's how you're going to do that. And then once you have that, you have time here. Look at what shows up here. I also have velocity as an option. So if I turn that off, I can also look at the graph of velocity versus time. And I can do the same thing. I can go into my edit graph options, make sure everything's scaling from 0, and see what that looks like. And there's my 2 velocity points right here. So you are going to have, and then once you have a whole bunch of points here, then you can do a curve fit for that. And you already know, because you've been paying attention when you're doing your homework, you already know that the slope of that this should be linear, right? If this is a velocity versus time graph, and we have constant acceleration, then this should be linear. And the slope of it should be the acceleration. That's what we're looking for. Okay, so you're going to write a lab report for me about this, and you are going to have lab partners for it. And I'm going to post who your lab partners are in the assignment. Okay, you're going to make contact with them. You're going to make a Google Doc, and you're going to share the responsibility for creating this whole thing. I'm going to make a suggestion for the way that roles can be divvied up. you'll all be in groups of 3, except for one of the groups is going to be a group of 2. So those people will have just a little bit more work to do. But no matter what your jobs are in the group, you need to look at all the stuff. The whole point of doing a collaborative lab report is not to just make it lighter work. That's nice, but you need to, it's to have 3 sets of eyes, 6 eyes altogether. Usually, well, I guess more sense like that. But to have multiple sets of eyes looking at the data and the graphs and the equations to make sure all the units are right and the procedure, yada, 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 all that stuff. This lab report, on the first lab report, everybody got 100 because it was our first one and it was great. This one, you can lose points for things like having a graph without a title, for having equations where you don't have units on your constants in the equation. All those things matter now. We'll be looking for the correct things to say in the conclusion. What are you going to say in the conclusion? You're going to say conclusion part 1, our equations. This is what it means, our equations. And then you're going to say in conclusion part 2, in general, there's these equations, right? And probably they're going to be like right out of the kinematics equations, right? Don't you think? Because we're talking about position and velocity of something in free fall, something with constant acceleration. So I think you're going to be good. And of course, I will answer questions for you. I'll put a due date in there and I'll be able to answer questions as you go through the project. I think you're going to be working on this over a weekend in this particular case. And I think I may be out of pretty much off the grid this weekend coming up. So I will make sure to make the due date such that you can have time to ask me questions, because that's fine. That's why we're here, to help each other. All right, so I think that that's good for your instructions. I hope that that's all clear. I'll add a couple little details in our in the Google Classroom assignment description.